How's everyone doing today? Everybody doing okay? Have a great weekend?
Yeah, pretty good week. Pretty good weekend.
Anybody else? Everybody else doing okay?
Yeah, thank you, Professor.
All right, I hope everyone's doing well. All right, so what I wanted to do today, obviously we're going to pick up where we talked, right where we ended class last week. And if you guys remember last week, I ended class talking about talk times on a random iPhone. Does that kind of ring a bell? Yay, nay?
Wait, what?
Hopefully it does. We'll do a review of it. Don't stress. But before that, I wanted to talk about what's going to happen over the next couple weeks in the class. So if you look on our course outline, I had to take a day off on the 20th, so I moved the schedule around today. So next week you were supposed to take the midterm in class, but I'm going to give it as a take-home assignment. So today's class is the last topic that will be on your midterm exam. So what'll happen is we'll come to class next week and I'll have the midterm posted for you online. But then I'm going to lecture on a completely new topic, okay? Topic that's not going to be on your midterm, okay? So your midterm is just going to cover, and you guys can see on my screen the syllabus there. It's just going to cover these topics right here. And you'll submit it just like you did the probability assignment. You'll take it home, you'll work on it, and then you'll save it as a PDF or a Word document, and then you'll submit it back to me. So if you look back in the classroom under the week 6 tab, under the post-class requirements, I put up a practice midterm assignment there for you. And this is just old questions that I've asked on previous midterms, just so you can see the type of questions I'm likely to ask. And then I've also gone ahead and posted the solutions for them. So you should give it a shot and then, check your answers against the solution set. It's just an extra way to practice. Okay, and then your homework assignment this week is just a little online quiz, and it's going to cover basically everything I talk about in class today. All right. Does anybody have any questions about any of that before I get started in the lecture?
Yes, Professor. I have a question on the midterm.
Sure.
So you said it's take home. So
yeah.
How long do we get to take it?
I'll give you a week to turn it in.
Okay, so like next class, like is that like how it is?
Yeah. So what'll happen is like loading this back up. The midterm will be posted on the 13th and it'll be due on the 20th. So you'll have a week to do it.
Okay, thank you.
Yeah, no problem. Any other questions? Yes, I'm sorry. I just, I'm a little behind on my grading. Yeah, I'm really sorry about that. I will definitely, I have a checklist. I don't do this very often, but I thought I'd turn my video on for you guys. I have a checklist of stuff to do today. So I'll make sure to put that on my checklist for you. Yeah, my fault. Sorry about that. Anyways, just hello for the people who have the video turned on. So I'd say hi to people. Any other questions? Okay. The other thing I want to say is go into the classroom if you haven't already done so. And under the course meeting materials, there's this thing called the standard normal table, this. And when you download it, it looks like this. Okay, have this handy. We're going to use it in class a little bit today. It's just better to have it. I hope you printed it out. It's just better to have it printed out so that you're not switching between like watching my video here and the table. And then also have your graphing calculators handy. I have both the TI-84 and the TI-83 emulator loaded up because we're gonna, during the second half of class today, we're gonna spend a lot of time using our calculators. Okay, so have those handy. All right, final questions before I get started? Anything? Okay. All right, so last class we were talking about the normal distribution. So today's class is going to be about what's called the standard normal distribution. All right, so let me start with the problem from last week, okay? So last class, if you remember what I said the iPhone 10's talk time is normally distributed with a mean. Does anybody remember what I said the average talk time was on the iPhone 10?
I think it was 20 hours. I'm sorry.
That's okay. Yeah, mean of 20 hours. Thank you very much. And a standard deviation of 5 hours. Okay, those were the numbers given from last class. Okay, so then what we also said was, suppose an iPhone 10 is selected at random and its talk time is recorded. Okay. So before we actually record the talk time, okay, we don't know what the actual talk time is going to be. So the outcome is a random value. So we're going to define this random variable. We're going to let the random variable x be equal to the talk time on a randomly selected iPhone 10. Okay. And this is what we know. All right. We know x, this squiggly line here, means follows or is approximately normally distributed. We know the mu, the average, is 20 hours. And we know the standard deviation is 5 hours. Okay. So last class, what we did was we talked about draw what we call the density curve for the variable x, for the random variable x. Okay. And the density curve just looked like this, just looked like a normal distribution. All right, how that one look okay today? A little bit better than last week, maybe?
Much better.
Yes.
Thank you. I hope it's a little bit better. I don't know if I told you guys, I tried to give up coffee last week. Did I tell you guys that?
No.
I tried,
Yes.
I failed, okay, miserably giving up coffee. I went a couple days and I was not a great person. So I'm back on coffee. So my normal curves are looking better. Okay.
Hop on the T wave.
Yeah. Yeah. I hope you guys appreciate the little jokes this morning, but that was true. So the high point of the graph occurs at 20, whatever the average was. Okay. And then if you remember what we did last class is we started adding standard deviations, 25, 30, subtracting standard deviations, 15, 10. Okay. And this is what the density curve looks like. So here's the problem that we're going to work today. All right. what's the probability a randomly selected iPhone 10 has talk time less than, let's say, 17 hours? Okay. So the way you would write it is this. You would say, what's the probability that X is less than 17 hours? Okay. Can anybody tell me why we couldn't solve this last week? So last week, if you remember, we did this empirical rule stuff with the normal curve, right? And so does 17 fall on a nice standard deviation?
No.
It doesn't. Okay, so we're going to need a different way to solve this, okay? So how to solve today? There's going to be two ways to do it, okay? During the first half of class, I'll show you using a statistical table. All right, this will be the by hand method. All right, and then I'll show you using your calculator. Okay, and you can do either or on the homework or on the midterm. It's totally fine, okay? I will show you, especially on the midterm, if you're gonna use your graphing calculator on the midterm, I'll show you how you have to write it out on your midterm, so I know you used your graphing calculator. So, you know, just either one will be fine. Okay, so we got this iPhone problem. Now we need to step away from it for a second because I need to introduce what's called the standard normal distribution to be able to solve this by hand. Okay. Anybody still copying, or is it okay if I go on?
No, Professor. Somebody asked in the chat if you can post the previous
Yeah.
grades.
And I said,
Oh.
yeah. It just honestly, it slipped my mind, and I
Okay.
really apologize for that.
No, it's fine.
It's not fine. I'm a terrible professor. I'm sorry.
No.
Could you say something?
You know, I'm sorry. Just so much is going on.
That was when you left the coffee.
Yeah, it was
That's
when
what
I left
happened.
the coffee.
Yeah.
Yeah. I'm sorry. It just slipped my mind, guys. I apologize. Just lots going on with work and personal life and stuff. So it just slipped my mind. But I'll get it to you guys today. I promise you I'll get it done. The grades might not get posted till like 11 o'clock though. I just have to put the kid down first. So, you know, we'll see. Okay. Anyways, back to the lecture. All right. So what we're going to need to introduce is what's called, to answer this, called the standard normal variable. Okay. And really what this is this is just z-scores. Okay. Do you guys remember we did this maybe 3 weeks ago, 4 weeks ago, maybe I talked about z-scores?
Yeah.
We did the example where we talked about teacher salaries, I think. And then I did the example where we talked about exam scores. So this is kind of just reintroducing z-scores. All right, so here's the definition. And this is what's called standardizing a normal random variable. So suppose the random variable x is normally distributed with mean mu and standard deviation sigma. Okay, and I'm just going to go back for 1 second. So like this is the random variable x, okay? This is what I'm talking about, like something like talk time on a randomly selected iPhone 10, okay? And it has some mean mu, in our case 20, and standard deviation sigma. So in the case of our problem, it's 5, okay? Then the random variable we denote as z, which is just equal to x minus the mean divided by the standard deviation, okay? So just what's going on here is you have the variable value minus the mean divided by the standard deviation. Okay, is also normally distributed. So what I'm saying here, as long as your random variable x is normally distributed, z-scores will be normally distributed. So now we're talking about z, okay? Mean. So let me ask you guys this in the chat, or if you want to say via audio. What are the 2 easiest numbers to work with in mathematics, do you think?
Even.
Say that again?
Even
Go on ahead.
even numbers.
Yeah, not even, because there's an infinite number of even numbers. Just like, what are the 2 easiest numbers in math, do you think?
1.
1 is definitely a very easy number. What else is another easy number?
0.
Yep, 0 and 1. So the great thing about this z-score is normally distributed. On average, it's equal to 0, and standard deviation equal to 1. Okay, z is called the standard normal variable. Okay, the standard normal variable. The great thing about z is it has the same properties as the normal curve. Okay, these same properties as the normal curve. So if you remember last week when we were talking about the standard normal curve, let me show you the properties again real quick. And I'll go back to the slide in a second. We went through all these properties here for the normal curve. All right, it's symmetric about its mean. The mean is equal to the median equal to the mode. Single peak, the area under the curve is 1. That's incredibly important. Area to the right or left of the mean is 1/2. We have that bell-shaped curve, and the empirical rule holds. Okay, these are the same properties. So Z has these same properties. Oh no, well, here we go. Okay, good. Same properties. So area under the curve is 1. That's important. Symmetric. And the empirical rule holds. Okay. Okay, so how this is great. So all this really is this is a variable transformation formula. But like why, what's so great about it? Okay. Or like, why do we care? So Is everybody okay if I go to the next slide?
Yes.
Anybody need a second? Nope. Okay. So what's special about this? Okay. So recall the iPhone example. Okay, X was the talk time. It was normally distributed. The mean was 20 hours. Standard deviation was 5 hours. So the density curve looked like this. So 20, 25, 30, 15, and 10. Okay. Let's see who remembers the empirical rule well. If I shade in the area from 20 to 25, does anybody remember what this area is equal to under the curve to go from the mean to 1 standard deviation?
Isn't it 34%?
Yes, perfect. Thank you. Very well done. It's 0.34. Yep. For the standard normal variable, okay, we call the standard normal variable Z, which was normally distributed. The average was 20 hours, or excuse me, oh geez. The average was 0 and the standard deviation was 1. Okay. What happens is if I draw the curve for this, it looks like this. It's centered at 0. And I'm going to start adding standard deviations. 1, 2, subtract a standard deviation. -1, -2. If the same rules hold, okay, what's the area under this curve between 0 and 1?
0.34.
Yeah, thank you. It's the same exact thing, okay? Same exact thing. So this area here, because the empirical rule holds, is the same as here. So it's like, that's cool, but check this out. So also, what's the z-score when x is equal to 25 here, okay? Well, z-score is equal to x minus the mean divided by the standard deviation. So if you take x, which is 25, minus the mean for that variable, which is 20, divided by its standard deviation, which is 5, you get 5 divided by 5, which is 1, which is what you see here. So like, 25 is 1 standard deviation from the mean. Check this out. On the z-score, that's 1 standard deviation away from its mean there, okay? How we use this, it's like, so what? There is a table of areas for the standard normal variable. Okay. So what we can do is, if I ask you a problem related to a random variable x, what we can do is we can transform that random variable x into a z-score and then use the table right here to find the corresponding area, okay? Now, it seems a little weird at first. Like, how many people are kind of like, this seems a little confusing, Matt, so far? You can be honest and just say a little confusing, or in the chat, a little confusing.
I'm a little
It
confused.
is. Yes.
Totally. Like a lot of this stuff, when you first see it, is confused. You know what I relate this to was the, you guys remember last week we did the uniform distribution and it didn't make much sense. But then after we did the first example and the second example, it was kind of like, oh, okay. I see what's going on. It's going to be the same thing here. Okay. Like, would you guys agree? Like last week with the uniform distribution, it was really weird until we did our first example or two.
Yes.
Yeah, it's going to be the same thing here. Okay. So I'm going to show you exactly what I mean by using the z-score to find the area on this table, and how we can go back and answer this question that we first started with here. Okay. All right. So what we need to now do is I need to talk about how you read this table. Okay. That's what we're going to spend the next couple minutes doing in class. Okay. So hopefully you have it printed out. If not, that's okay. You can just watch me do it, and like, you know, alt tab between my lecture and the table. Either one is fine. All right. So first, what we need to do, we need to learn how to read the standard normal table. All right, if you look at the table here, you notice that it's 2 pages. Okay, you see something that looks like this, and then you see something that looks like this. Two pages seem good to everybody?
Yep.
Yep.
This is so cool. I love this. If you look here, do you see how it has this little z variable on the table there?
Yeah.
Yeah. So, you know, check this out. Z. So this table references this z variable. And what you'll notice here is you have this normal curve, and then it has this z value. And then what it has here is it has this area shaded to the left. Okay, area shaded to the left. This little gray shaded area here, this part of the table deals with negative z-scores. And then if you scroll to this one here, you see z and then a lot more of the area shaded in. This table right here deals with positive z-scores. Okay, so what the table does is the table shows the area to the left of a z-score. Okay, and this is important. It shows all the area to the left. Okay, it shows literally all the area to the left. All right. So there's 3 ways we're gonna have to talk about reading the table. Okay, the first one here is the easiest one. It's finding areas to the left of a z-score. Okay, finding areas to the left of a z-score. Okay. So let me do 2 examples of this. After you see the first one, it'll be like incredibly easy. Let's find the area to the left of z is equal to, let's do negative 1.23. Okay. People are probably not going to like this, but, or maybe do. Every problem we do, I'm going to draw a sketch of it because the sketch really helps me understand the problem. So this is what I know about whenever I see a Z, okay? A Z-score or a Z variable represents the standard normal variable, which is centered around the number 0. And I want to be the area to the left of negative 1.23. So I'm going to go to negative 1.23. None of this at any point now needs to be drawn to scale. This value here, negative 1.23, is obviously just to the left of 0, right? Because it's a negative number. And it's just drawn so that I know what I'm looking for. And then I want to find the area to the left. So I'm going to shade this little area here, okay? Well, look at the table here. Does my little drawing here kind of look like this one here?
Yes.
Yeah. I mean, I personally think my drawing is better than this professional one, but we'll let it be. Okay. This is where everyone's supposed to say yes, totally, Matt, but that's okay. All right, so you'll notice when you read the table here, you see this part up here called Z, and then there's a bunch of column numbers, and then there's a bunch of row numbers at the top. The way you read the Z-score is this column value, you go to the first 2 digits of the Z-score, which is negative 1.2. So go down on your table till you find negative 1.2, okay? Then the last digit on the Z-score here is a 3. So you're going to go up to the top of the table here till you find the 0.03 because the last digit's a 3. And then you're just going to look where the row and the column intersect. So negative 1.2 till I get over to 3. Can anybody tell me what area you see right there?
0.1093.
Mm-hmm. And that's it. That's the area right there. So this little red shaded area is 0.1093. Was that table pretty straightforward to read?
Yes.
Yeah.
Yeah, I think it's pretty straightforward. Now let's answer this question. Okay, let me ask you another one. I'm going to change it up a little bit. Let's find the probability that a Z-score is less than 0.75. Okay. All right, so this is weird, right? Because now I just asked you a probability question, okay? Right? So what you have to remember from last week is area under the curve. Is the probability. Okay, so what I'm going to do is I'm going to sketch this. Here's the standard normal curve. So whenever I see a Z, standard normal curve, centered at 0. And now since the value I'm interested in, 0.75, is greater than 0, I'm going to go over to the right. And if I want to be less than 0.75, what I'm going to do is I'm going to shade in everything to the left. Okay, so now I just need to find this area. All right, you notice how this is a positive number here? So whenever you see the positive number, you're going to have to go to the positive side of the table. And remember, our Z-score was 0.75. So you go to the first 2 digits, 0.7 right there. You scroll over till you get to the last digit, which is a 5. And it looks like 0.7 and the 0.05. What number do you see right there? Yes, thank you, Jessica.
734.
0.7734. So that means this probability is 0.7734. Not too bad?
Professor, I just had a quick question.
Of course.
So do we ever round up or anything like that, or we just go based on, will it always be two numbers?
Yeah, so you'll notice when we work our first application problem, you'll notice, and that is a fantastic question, that the z-scores only go to 2 digits, right? Or 2 decimal places, I mean. So whenever you work an application problem, you're going to have to round it to 2 digits. Yes.
Okay, thank
And
you.
yep, and you should round up and round down accordingly. Okay. And I should note that'll only be an issue when we do this by hand with the table. When I show you how to do with the calculator, it won't matter at all. Okay. All right, so areas to the left. Whenever you see a shaded area to the left, it's like a piece of cake to do, okay? All right, so there's 2 other ways we need to talk about more on reading the table. The second way you got to learn how to read the table is finding areas to the right. So this is weird, right? Because like if you look at the table here, the table only gives areas to the left. So it's like, shoot, what are we going to do? So let's find the area to the right of the value 1.06, okay? So what I'm gonna do is I like to draw it, okay? I'm sorry, z is equal to 1.06. So it's centered at 0. 1.06 is off to the right. And I'm going to shade this area here to the right. Gosh, I don't know how to do this problem. Does anybody, I'm just curious, does anybody have a suggestion?
Yeah, just do the like the reciprocal of that number.
So you kind of get there. What do you mean by reciprocal?
Or just like you do the negative version basically.
Yep. So there's absolutely 2 ways you could do this. One way is to just look up negative 1.06 because the curve is symmetric. The other way to do it, and the way I will tackle it in class, but your way is totally fine, by the way. The way I'm going to tackle it in class, does anybody remember what the total area I said was under these curves?
1.
Yeah. All right. So let me look up 1.06. Okay. 1.0, and then I'm going to go over to 6 is 0.8554. Okay. Everybody see that? 0.8554. So that's the area to the left of this value. So that's the area this way. Well, if that's the area I am not interested in, okay, I'm not interested in it, then the area to the right is just 1 minus that, which is 0.1445 or 446. Yikes. So you can do it that way, or as was mentioned, if you actually go look up negative 1.06, you get the same thing, 0.1446. So whichever way you prefer. I like the 1 minus method instead of flipping it and looking up the negative, but that's just me. So even though the table gives area to the right, or excuse me, the table gives area to the left, you can just find area to the right by just doing, just by looking it up and subtracting it from 1. Okay, make sense? And don't worry, we're going to practice this still too, more. Yay, nay.
Yay.
Everyone else is like, I wish I had registered for algebra.
I'm just trying to digest it, like look it over.
I understand. And let me do the next type of way to read the table. And then we'll work application problems, okay? The last way is finding areas between two numbers. Okay. So let's find the area between z is equal to, let's do negative 0.09 and z is equal to, let's do 2.01, okay? So to help me do this problem, the first thing I do is I sketch it, okay? So I'm going to draw standard normal curve. It's centered at 0. Over here is negative 0.09, and way over here is 2.01. So I want to find all this area between these two numbers. Okay. Ooh, man. Does anybody have a suggestion on this one?
Yes.
Okay, what's your suggestion?
Basically, you get the standard normal, like whatever the decimal is, of 2.01,
Okay.
and that's the left, and then you could subtract it by the z-score of the left of negative 0.09.
Perfect. So let me just show everybody how we do that, okay? So start by looking up this 2.01, okay? So you got to go to the positive side. So 2.0 and then 1 here. You should get 0.9778. That's looking up 2.01, 0.9778. So that's the area from here all the way this way. So 9,778. But I don't care, or I don't want the area to the left of negative 0.09. So let's find that area. So I got to go back to negative 0.0 down here. And then the last column is the 9. So I got to go all the way from here to right here. And do you get the value 0.4641?
Yep.
Yep.
Okay. So but I don't care about this unshaded area. So if I don't care about it, I'm going to have to take it away. So the area between is you just subtract them. Is it 0.5137? Did I do that correctly in my head?
Yep.
Thank you. And that's just the area. All right. All right, so what do you think? Not, at least, I'm going to do an example of each of these next, but does it maybe not seem too bad? Little like, is at least reading the table pretty straightforward? Let me ask that question.
Yeah.
Yeah, it is.
All right, so now let's go back 40 minutes ago and answer this question now. Okay, what's the probability that x is less than 17? And this example is just like how you do application problems. And my son just walked by and he just let out a cry because he's just like, oh, application problems. Oh no. I hope you got a little laugh out of that. All right, so recall talk time on the iPhone 10 is normally distributed. With mean is equal to 20 hours and the standard deviation was equal to 5 hours. Okay. If an iPhone 10 is selected at random, what's the probability the talk time is less than 17 hours? Okay. So here's what I'm going to do. I'm going to do the problem on the left-hand side here, and I'm going to write the steps that will follow on the right-hand side here, okay? So the first thing you're always going to do when you tackle these problems is you're going to define the variable and you're going to write the probability statement. Okay, so over here, step 1. All right, we're going to let X, because we don't know the talk time, be the talk time on a randomly selected iPhone 10. Okay, we know X is normally distributed. We know that on average you get 20 hours and the standard deviation was 5. All right. So I want the talk time, I want to find the probability that the talk time X is less than 17. Okay. The second thing you'll do, and I highly recommend this, okay? I will say this, a lot of times for as long as I've been teaching this class, 10, 11 years, I guess I've been teaching this class. I know it might seem confusing right now, but after we do more examples, it'll be like, this is so easy, this is straightforward. The majority of ways students miss the problems is they don't do this next step and they misinterpret what they're looking for. Okay, so the next step here, what I do is I draw the density curve and shade in the area you're looking for. Okay. So step 2 over here, you're going to draw this bell curve. It's centered at 20. 17 is over here to the left, and you want to be less than. Okay, you want to be less than 17. So am I going to shade area to the left, or am I going to shade area to the right?
Left.
Yeah. So I want to find this red shaded area here. Okay. And just so we're clear, this is not 17, 20. This is the number 17 and 20 is down here in the middle. Well, this is so cool. All right, look at this. I've got this shaded area to the left. Does this curve look just like this curve now?
Yes.
Okay, but this curve only works with z-scores. So what I need to do next is 3. I need to convert values of interest to z-scores. So my z-score formula is z is equal to the x value of interest minus the mean divided by the standard deviation. Okay? Well, this is 17 is my x value of interest. The only one we have here is 17. You don't need to do a z-score for 20 because the z-score for 20 would just be 0. So whatever the mean is, the z-score is always just 0. So this is 17 minus the mean, which is 20, divided by the standard deviation, which is 5. So this becomes minus 3 over 5, which is just minus 0.60. Right. This question was asked earlier, but just it was a great question. Just remember, because the table only goes to 2 decimal places, round to 2 decimal places. Always, always, always. The fourth thing you do is you rewrite the probability statement with the z-score. So this up here just becomes now, hey, what's the probability of z-score is less than minus 0.60? And then 5, the last thing you do is you use the table to find the area. So now this problem is just, okay, what's probably a z-score is less than minus 0.60? Well, I'm looking for an area to the left. So I can just literally go to minus 0.60. And what do you get? Do you get 0.2743?
Yes.
And that's it. That's the answer. So minus 0.6 and then 0 is right here. You get 0.2743. And that's your answer right there. What do you guys think?
I love it.
Not too bad. It's okay.
It's okay.
All right. Want to see me do another one? Before we take our break, let me do a couple more just so we stick to this same problem. Sound okay?
Yep.
Sure.
Okay. Plus, just between you guys, I can hear my son is having a hard time going down for a nap. And if I take a break now, I'd have to go help. So why don't we just, stay here? No LOL there?
That was funny.
All right. Don't judge me harshly, okay? So now here's the next problem. So it's just sticking with the same thing, okay? You're gonna, if an iPhone 10 is selected at random, okay, same problem. Part 2 now. What's the probability the talk time, let's say, is greater than, let's do 26 hours, okay? All right, so you're just gonna follow the same steps to do this problem, okay? Step 1, we've already defined the variable, so let's just write the probability statement, okay? So I wanna find the probability that my talk time is greater than 26, okay? What did I say you should always do next? What do I say?
Draw.
Yeah, I just draw it, okay? It'll really makes the problem easier, okay? So we know that talk time is normally distributed. It's centered at 20, and I want to be greater than 26, okay? So would I shade to the left or to the right?
To the right.
Just like this. All right, so now I want to use my table, but before I use my table, what do I need to do next?
Convert to z-score.
Convert to z-score. So z is equal to x minus the mean divided by the standard deviation. Well, this 26 is my x value of interest. Okay, so it's 26 minus the mean was 20, and the standard deviation was 5. So this ends up just being 6 divided by 5, which I think gets you 1.20. Okay. So now this becomes, hey, what's the probability that a z-score is greater than 1.20? Well, how did I tell you to find areas to the right? Because like if you look here, the area is shaded to the right.
One minus.
Yep. So it's just going to be 1 minus. I'm going to go to my table. 1.2 is right here. 0 is right here. So it's 1 minus 0.8849. Okay. So 1 minus 0.884. I already forgot it. 9. Which ends up being just 0.1151, I believe. Not too bad. Now that you've seen me do a second one. I can't.
Yes, good.
I got one yes. Okay. All right, let me just do one last one and then we'll take our break here, okay? What's the probability the talk time, let's say, is between, let's do 18 hours and 23 hours, okay? So this is just what's the probability that my x is between these two numbers, 18 and 23. Okay, I really think the drawing helps here, okay? So I'm gonna draw my standard normal curve, or my normal curve, excuse me. It's centered at 20, here's 20. 18 is somewhere over here. 23 is somewhere over here. And I'm gonna shade in the areas. Okay, so for this problem, how many z-scores am I gonna need to compute?
2.
Yep. So I'm gonna need to do the z-score for 18. So it's 18 minus 20 divided by 5, which gets me minus 2 divided by 5, which gets me minus 0.40. And then I need to do the z-score for 23. Which is 0.60 when you just do that real quickly. So now this becomes, what's the probability that a z-score is between negative 0.40 and 0.60? Okay, what was the procedure for this?
Rewrite and maybe redraw.
So you don't need to redraw it. You can redraw it, but like, so I have two z-scores, right? So you're gonna look up, if you remember, you look up the higher value, which was 0.60, 0.60, which is 0.7257. And you're gonna subtract away, you're gonna look up the bottom z-score, which is minus 0.40. So minus 0.4 and then 0 right here is 0.3446. And you just need to subtract those two. So let's do that real quick. So it was 0.7257 minus 0.3446. And you get this, 0.3811. And that's your answer. So what do you think? Not too bad, bad?
Not too bad.
All right, I hope it's not too bad. So here's what we'll do now, okay? Let's just take a quick break. And what we'll do when we come back, so let me just, before we take the break, let me just say something here. When you go look at your homework for this week, okay, it's a little online quiz that you have 2 attempts on. The first 1, 2, 3, 4 questions just ask you how to read the table. Well, that's what we spent about 20 minutes doing. And then questions 5, 6, 7, 8, and 9, they just ask you to do this application type problem that I just did. So you actually have enough information right now to be able to do your homework, okay, which is good. So what I want to do during the second half of class is show you how to do problems like 5, 6, 7, 8, and 9 even easier, okay, so on your calculator. So if you're kind of like, this z-score stuff is not that easy and reading the tables a little confusing, we'll I'll show you how to use your calculator. Okay, sound good?
Yes.
Okay.
Yep.
So it's 10:03. So let's take a break. Let's start back at 10:10. Okay, so we'll just take a quick, a little bit, 5-minute break. Okay. And it's my sister's birthday today, so you guys can see the reminder there.
Happy birthday, Nikki.
Yep. So I should probably give her a call today. All right, guys, I'll see you in 5 minutes. All right, can everybody hear me okay?
Yep.
So as we do this next example, have either your TI-83 or your TI-84 calculator handy, because I'm going to show you, we're going to first do the first problem by hand, and then I'm going to show you how to do all of this stuff with your calculator, and it's awesome, okay? So I want to do an example about Chips Ahoy cookies. How many people have heard of Chips Ahoy cookies?
Yes.
Okay, one person.
Yep.
Everyone else?
Two.
Yeah, like
Yes.
Okay, good. I don't know, people, I'm not sure if people remember this. So this was something from my generation when I was growing up as a kid. They used to have this advertising commercial. Okay, so I grew up in the late 80s, early 90s as a kid. And so, you know, we always had you know, like Saturday morning cartoons were like a big thing when I was growing up. And so, you know, you watch cartoons, you see commercials. So they always used to have the Chips Ahoy cookies used to run this commercial that said, there is 1,000 chips in every bag. Okay, so they used to run this advertising campaign that said this. Okay, I'm just curious. Does anybody remember this from maybe from their childhood? They might not. I got one yes. Somebody remembers that. So they had this big advertising campaign, you know, whenever you buy, and it was an 18-ounce bag of Chips Ahoy cookies, you're getting at least 1,000 chocolate chips in your cookies, okay? In your bag, I mean. But do you notice that they don't do this advertisement scheme anymore? Like it's not a thing. So there was actually a study done, okay, about this. Okay. So there was a study done to test this. So this statistics professor at, I always find this hilarious. The statistics professor made his students open up bags of chocolate chips, Chips Ahoy cookies, and literally count the number of chips in the bag. Okay. Does that sound like fun?
It's a lot. No.
No, it sounds terrible to do. So like, you have to think about like what college across the country that a professor could literally force his students to do this. I'm just curious. So this study was done like, you know, over a decade ago. I'm just curious, does anybody have a guess what college or university the professor could like force the students to actually do this and they have to obey?
WCC.
Yeah, no. This was done at the United States Air Force Academy. Okay, so because the students are cadets in the Air Force, they have to follow orders. So the professor was like, hey guys, you know, let's literally count the chips in the bag, okay? So anyways, they did this study and this is what they found. They found that the number of chips in the bags. So let me ask you this before I give you the next information. Do you think every bag contained exactly the same number of chocolate chips?
No.
No.
Okay, why not? You're right, they didn't. So like think about like an assembly line that makes these chocolate chips, right? Like there's just this big vat of dough with chips in it and they just like plop them down before they make the chips. So like there's no way it could be uniform, right? So the manufacturing process introduces some variability. So they found that the number of chips in bags was normally distributed. with a mean of, they found that on average there were 1,262 chips and a standard deviation of, let's say, what was it, 118 chips. Okay. So now here's the question. If you select a bag of Chips Ahoy at random. Okay, so imagine you go to the grocery store and you open up you just take a random bag off the shelf, okay? What's the probability the bag contains less than 1,000 chips? Okay. So let me give you just a little bit of advice here. Whenever you see the words normally distributed, mean, and a standard deviation, okay? And then I ask you for a probability, all right? You're just gonna use these steps right here, okay? Always, 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 all right? So step one, okay? You're gonna define the variable. So before I count the chips in the bag, do I know exactly how many chips are gonna be in the bag?
No.
No. So I'm gonna let X be the number of chips in a random bag of Chips Ahoy. And I want to find the probability that the number of chips in that bag is less than 1,000. So basically what I'm saying, what's the probability that they're lying, that there is not 1,000 chips in every single bag, okay? Well, I know that the number of chips are normally distributed. So they follow the bell curve. The high point is going to be 1,262 chips. And I want to be less than 1,000 chips. So am I going to shade to the left or to the right?
Left.
Yeah. Shade to the left here. So the next thing I'm going to need to do is a z-score, which is the X value minus the mean divided by the standard deviation. Well, my X value here is 1,000 minus the mean, which is 1,262. Standard deviation is 118. So let's grab our calculator to do this. Yeah, come on. So I know this seems weird, but there's a common issue that I always see with students. Oh, calculator. I always see this error on exams. You don't want to do this. Like, did I just plug this correctly into my calculator?
No.
No,
Why not?
because you're just dividing like that part.
Yeah, you have to put the top in parentheses. Always remember that. So it's a parentheses, 1,000. And you should get this. Okay, it's minus 2.22. Okay, because you're going to round this always to 2 decimal places. So this is now the probability that a z-score is less than minus 2.22. So it's an area shaded to the left, so I can just literally go to my table go to minus 2.2, and then over to 2, and I get 0.0132. Okay, 0.0132. Does everybody see that?
Yes.
So there's a non-zero chance. So were they making a false claim? Did every bag contain at least 1,000 chips?
No.
Okay, yeah, and that's why. So the cadets at the United States Air Force Academy showed this, and you know what? They had to pull the ad campaign. All right, so regardless, right now, just doing it by hand, okay? Does it seem pretty straightforward?
Yep.
Yeah.
Do you guys think you can handle a question like this on the midterm?
Definitely.
Okay. How about I make them even easier for you now? Okay.
Please.
I know what everybody's thinking. Like, Matt, why don't you just lead with the calculator and save us this time? Nobody wanted to get in the chat and be like, yes, that would just be preferred. But okay. So everybody, I highly encourage you to do this, okay? Because we're going to be using our calculator a lot next week too, okay? Because next week is kind of just an extension of this. So knowing how to use your calculator is incredibly important, okay? So I'm going to do it on both calculators here. The TI-80, it's a little bit easier on the TI-84 calculator than it is on the TI-83, but just because the TI-84 just literally makes it foolproof for you. So does everybody on their calculator on the TI-84, do you see this button that says DISTR? And then over here on the TI-83, it says DISTR?
Yep.
Yes.
Okay, what this stands for is distribution. So you have to hit second function to get to it. So second function, all right. And what did the first two things say? Does everyone see normal PDF and then normal CDF?
Yes.
Okay, so we've actually talked about PDF. It stands for probability density function. For these problems, what we actually want is option number 2. Okay, so you always want what's called the normal CDF. So what the CDF stands for is the cumulative density function. So it finds a cumulative area, which is what this is. Okay, a shaded area over an interval is a cumulative density function. So for option number 2, everybody just hit enter. Okay, so if you see on the TI-83, it just says normal CDF and then in parentheses, and then what you'll see here on the TI-84, it looks a little bit easier. It says lower, upper, and then this is mu and sigma, okay? So what the lower value represents is like your starting value, okay? And this is where it gets a little confusing. Because it's an area to the left, okay? Do you guys see my mouse down in the bottom left-hand corner?
Yep.
Okay.
Yeah.
So my mouse is saying, I want the area to the left, all the area to the left of 1,000. Okay, so 1,000, this value of 1,000 is actually the upper, okay? So to put the lower, you're always gonna put a ridiculous number like -9999, okay? So with the TI-83, what you have to do is you have to press, don't do the subtraction, you have to press -9999, okay? On the TI-84, you're gonna hit enter, and then the upper is the stopping value. So you're gonna go find the area all the way up to, and you're gonna stop at 1,000. So you're gonna put 1,000 there. Over here, what you have to do is, do you see on the TI-83, you see this comma button? You're gonna have to press comma, and then type in the stopping value, which is 1,000. Over here, the next thing it asks for you is the mean.
Oh, wait, where's the comma, Professor?
Yeah, no problem. Do you see my mouse on the TI-83?
Oh, yes, got it.
Good, 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 good. Ah, poor William. Can you guys hear him in the background?
He sounds so cute.
Yeah, I mean, you know, objectively, I think he's a 10 out of 10, but, you know, sometimes he has a hard time going down for naps.
Aw.
So the average is the average chips in a bag, which was, what was it? 1262. So you're going to put 1262. Over here, you have to put the average in next. So it's 1262. You're going to hit enter over here. The standard deviation was 118. So over here, you're going to have to hit comma 118. This is why it's a little bit easier on the TI-84. Then you just go down to paste and it puts it right in for you. So over here, you just have to close the parentheses, okay? So look, this is what we said the answer was. We said it was 0.0132, okay? On your calculator, now just hit enter. How many people got this?
Yes.
Yep.
Okay, well, look at that. They got 0.013197. So the only reason theirs is different than ours is because we rounded with our z-scores, you know, and the calculator actually goes out more decimal places. So look, it's still just 0.013 when I round it to. Is the calculator pretty straightforward? Easier, not easier? We got to do a little bit more practice with it.
Yeah.
Okay, but let me just show you how you have to put this in your calculator on the midterm. So like after we do one or two more examples, if you got a syntax error, Jessica, you probably forgot a comma. So we're going to do another example in a second, so you'll get a chance to practice it, okay? Is that okay, Jessica? Yeah, don't worry about it. Okay, so it always goes like this. It's always equal to the normal CDF, and the options are the lower value, the upper, then you put in the mean, and then you put in the standard deviation. All right, so for our problem, here's what we did. We did normal, CDF, and then we put in a ridiculous lower value, like negative 99999. Then we went up to 1,000. And then the mean was 1262. And the standard deviation was 118. So here's the thing. If you're going to do your calculator on the midterm exam, you have to show this work. You have to literally write out that this is what I put into your calculator. If you're going to do it by hand, you have to show what your z-score was. And then you can just write the answer. So either one is totally fine. Okay. All right, how about we do another one with the calculator though? All right. So let's stick with the Chips Ahoy stuff, okay? So here's the question. What's the probability a randomly selected bag let's say contains, let's say more than 1,300 chips, okay? So I want to find now, we've already defined the variable in the previous problem, so it's good. So I want to find the probability that the bag, the number of chips in a randomly selected bag are more than 1,300 chips, so greater than 1,300. Okay. No, Heather, no, it really depends on the context of the problem. So this one's different, and I'll show you like how you have to put stuff in, okay? So like, let me ask you guys this question. What do I say is always the most important thing to do these problems correctly. Does anybody remember what I say I always do?
Draw.
Draw, yeah. So like Heather has a great question in the chat, like, you know, is the lower bound always negative and the upper 1,000? Like it just really depends on the drawing. So I'm going to draw a normal curve. Okay. The average number of chips in the bag was 1,262. And I want to be greater than 1,300. Okay. So am I going to shade to the left or to the right? I want to be greater than 1,300.
To the right.
Right.
To the right, yep. Okay, so now I want to find the area. This is why the drawing helps me. I want to find the area starting at 1,300. So is 1,300 going to be my lower or upper value, do you think?
Lower.
Lower.
Yeah, because I'm starting at 1,300. All right, so here's how you're going to do this in your calculator. It's always the normal CDF. So let's load up our calculators again. All right. Man, my emulator hates me on this thing. Okay. So it's always go to your DISTR. So second function distribution. Second function distribution. And you want normal CDF. So you're going to scroll down to normal CDF. And you're going to hit enter. Okay, so the lower value is the starting value. So we agreed that we're going to start at 1,300. That's why the drawing helps. So the first thing you put in is the lower value. So it's 1,300. And then you're going to press the comma button. So it's 1,300 comma over here. Now the lower was 1,300 here. So the upper, you're going to put something ridiculous, okay? So the lower ridiculous value was negative 99999. So what do you think I'm going to put for the upper here?
Positive 999.
Yep, positive 999. Okay, so over here, you're going to have to go 9999 and then comma. The good news is on the TI-84, it saved the mean and standard deviation from the previous problem. So, but over here, unfortunately, you're going to have to go back 1262, comma, 118, and then close the parentheses. So here you can just go down to paste. And you should see this in your calculator, okay? How many people have what I have on my screen here?
Yes.
Okay, all right. So if you're gonna get a syntax error, it's usually because of the commas. You just have to pay attention to those. So let's just hit enter. How many people got this now on their screen?
Yep.
You got it, Jessica? Yeah, usually the syntax error, it's just a comma thing. Like there's like, you know, even I get them when I do these problems, you know, you're just like, oh, damn it, my fat thumb pressed something wrong or something, you know, in my case. All right, so all you're gonna have to do, the answer is 0.3737. So you just have to write the lower value, which is 1,300, comma, the upper value, which was 9999, comma, the mean, which was 1262, comma, the standard deviation, which is 118, close the parentheses, and that's your answer right there. Easier than the Z-score stuff? Now that you've seen me do a second one? I'll be honest with you, I totally think it's easier. there's less, I personally think there's less chance of a mistake when you do it with your calculator. Yeah. Let's do one more with this, okay? And then we'll end class after this next example. Sticking with the Chips Ahoy, just so you can see now, I did a left-tailed probability here, an area shaded to the left, and then I did a right-tailed. So let's just do an area between, okay? So you can see how to do that in the calculator. So what's the probability a randomly, let's say, selected bag has between, let's say, 1,100 chips, and let's go crazy, let's do 1,400 chips. Okay. So I now want to find the probability that the number of chips in the bag is between those two values there. Okay. So I know it seems silly, but what really helps me?
To draw?
The drawing, yeah. I always joke around, I should have been an artist. You know, with my handwriting and stuff, I would have been a great modern artist. Thank you for that pity laugh. Okay. So the high point is at 1262. So I want to be between 1,100 and 1,400. So I want to shade the area between. So I want to find the area. Listen to how I say this. Starting here and ending here. Okay. So the normal CDF. You need the lower. You need the upper. You need the mean. And then you need the standard deviation. All right, so what do you think my starting lower value will be for an in-between here?
1,100.
Yep. What do you think my upper is going to be?
14.
Yep. And then the mean is still 1262, and the standard deviation is 118. Okay. So you're going to go second function distribution, normal CDF. You're going to start at 1,100, comma, you're going to go to 1,400, comma, 1262, comma, 118. Close the parentheses. Over here, second function distribution, normal CDF. You just have to change the lower to 1,100 and the upper to 1,400. And then just go down to paste. And look, do you get 0.7940?
Yep.
Yep. Wow, what do you think? Calculator?
Yes.
Yes, use the calculator. Okay, that's honestly my suggestion for you. Okay. All right, so I'm just going to stop the video for a second, or stop the recording,